Well, hello. Welcome to what sure is to be an entertaining video lesson for you today. We are again continuing through our supplemental lessons that goes with Unit 1, and today we're talking about statistical graphics. So pictures that help us see statistical data, and what we can look at with that data. So if you real quickly we'll review some of the ones we did in the first unit. Dot plots. Remember, the benefit of doing a dot plot is you get a very nice picture of the individual frequencies of the data. It's great when you are going to explain the characteristics of the distribution. Remember, CVS cog, center, variability, shape, clusters, outliers, granularity, all of that. We also looked at stem plots, also known as stem and leaf diagrams. And the nice thing about stem plots is it's a very quick and organized way to see all of the individual data points and have it in an easy to see and clear manner. Right? Nice way of seeing the mode of a data set. And find median and really the rest of the 5-number summary. The histogram is just another name for a bar graph. And in one of our previous discussions, we actually went into much deeper description of how a good frequency distribution or a histogram should look. And then the last one was box plots or box and whiskers. And remember, the benefit of that is to get a very good picture of the 5-number summary, including outliers. As you see that little asterisk I put on mine just now, that would be an outlier. And so you know your 5 numbers here are going to be your minimum value, your maximum value, and then in between your quartiles. So that middle 50% represents the box, and the whiskers represent the outer 40%. Alright, so that's a little quick review over the old ones. So I've got a number of new ones for you now. What I'd like you to do is, after I switch screens here, I'd like you to push pause and take a few moments to copy all of these down, read through them, try to picture in your mind what exactly it's describing, and then we'll do some examples with a few of them. Alright, so here we go. I'll bring this up for you. Push pause anytime. Okay, so you have all those copied down now. Now we'll look through a couple of examples of each of these, just so you can kind of see not just how to do them, but the information that you might gather, the trends you might see from them. So the first one we're going to do is a frequency polygon. And if you remember from the earlier screen, all this is basically a connected frequency distribution. Instead of having bars, you're going to have some points connected by lines. So what I'm choosing here, these are the number of wins that Frankenmuth and Millington have had in varsity football over the last 10 years. Alright, what I'd like you to do is to try to make a frequency polygon. Try to make a frequency polygon. All that is just to create a connected line graph of these frequencies. Alright? And then once you do that, make some observations about it. So push pause right now and try it yourself. Alright, so you may have done a couple of things. Maybe you chose to make each individual number its own graph or its own class. Alright, and so you might have something that would look like this, and you got 0 wins, 1 win, 2 win, all the way up to 11 wins in the case of a couple years for Millington. Alright, to me that's a lot of bars. That's more intervals or classes than I really choose to do. So I'm going to group them a little bit differently now. I'm going to group them instead every 2 wins. So my classes are going to go 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9, 10 to 11. That's just the way I'm choosing to do it. I think I can still see the trends that I want to see doing this, and it's not so many data points on my frequency polygon. So I need to try to figure out how many what's my frequency for each one. I'm going to use red for Frankenmuth. I'm going to use green for Millington, and so I'm going to start making some tally marks here below so I can see what those values are. So I've got couple. I got an 8, I got a 6, another 8, 5, 8, 4, 3 way over here, and then a 5, a 6, and then a good year last year with a 10. All right, so when I plot those, just like I would plot a bar graph or even a dot plot almost, if you will, I'm going to put those values in, and I should label the left-hand side just so I can see what those actually are. All right, but what I can do is I can connect those. And if I was to connect those lines straight down to the bottom of the graph, it would make a polygon, make a closed figure. Then I can do the same thing for Millington now. And I'm tallying all those up. I've got a 5 and a 9, a couple 6s, a 9 and 8, a couple 11s, 10 and 9. Now I can do the same thing. And I can plot those points. And what I want to do is not just do these points and see where they go, but to see some trends. Alright, again, I could draw those straight down and connect those down and make a polygon out of that. And I can look and see, hey, what do I see here? Well, it's pretty obvious that over the last 10 years, Millington's had more success than Frankenmuth has. The center is further to the right, you know, those type of things. Alright, next one. This is an ogive. That's how it's pronounced, ogive. It's a good, nice, fun word. And what we'll do this time is we'll keep with the football theme, and these are weights on this year's football team, all individual players. And I'm making this up. I don't know if these are right or not. I'm just going to come up with about, I don't know, about 30 players and what their weights could be. So if you want to jot these down, you can, or you can just pause the screen here when I'm done, and you can attempt to make an ogive of your own. Now remember, an ogive, it's a cumulative frequency graph. So what that means is when you plot each of those points, it's not the data that falls within that interval or that class, it's everything up to that, everything included up to that. So it's a running total, if you will, of everything up to and included in that. Alright, so try that. Go ahead and push pause. Alright, once you did it, again, it's, how you created your intervals is up to you. I see that there is about 135 for my range. I'm going to split that up every 20 for my intervals. That will give me roughly 6 or 7 classes right now. So I'm going to do, let me see here, I'm going to go back, I'm going to change this to 120 to 139, and then 140 to 159, and so on and so forth. Again, do you have to do it like that? Certainly not. To me, it was just easy numbers to use. It gave me an appropriate number of classes, and all of my intervals are roughly the same size, have the same potential to fill each one. Now I want you to see what I do here a little differently, and I'll try to explain this as I graph this now. I've got my I'm just kind of putting tally marks here at the bottom so I can see how many I have here in each one. And what I'm going to do now is I better put a little scale here over here on the side just so we can keep track of where we're at. So every one of my little marks over here is going to be worth 5. And so my first dot, hey, that's just like it would be a normal frequency. I got 5 in that group. But now since I have 2 in this group, I'm going to put a dot at 7, not at 2. So you're never going to see the bar go down. Alright, you cannot go down because down would mean a negative frequency. So even if it's 0, there is nothing in that interval, it's still going to go horizontal. It's not ever going to go down. And so again, I'm increasing here. I had 5, and then I had 7, and then I was up to 12, and now I'm up to 18. And then in this group I have what, 4 more, so I'm up to 22. Remember, 22 players on the team weigh 218 pounds or less. 3 there is 25, and then I've got my last 2 guys and there's 27 players, and you can see that the line is constantly going up, or the data is constantly going up. You could connect those with a line if you like, but just remember, this is cumulative. That's one of the major mistakes of either creating or interpreting an ogive, is that those are cumulative frequencies, not individual frequencies within an interval. So that data point right there that the arrow is pointing at, like I mentioned earlier, that is 24 or 25. I can't remember if I miscounted there. That is the number of players that are at or below that weight class, at or below 239 pounds. Not there are 24 guys that are between 220 and 239 pounds. Hope that makes sense. The next example we'll look at, I think these two kind of come together a little bit. Both of these are good ways to look at qualitative data, not just cumulative data. I'm sorry, or qualitative data, not just quantitative data. So I've gathered some data here on people's favorite ice cream flavor, and I've got 41 people indicated vanilla is their favorite. I've got 30 that indicated chocolate is. I've got 15 that said strawberry is. I've got a handful of people that told me cookies and cream is definitely their favorite. And then I've got just a few that said Moose Tracks is their favorite, which just, by the way, is my favorite as well. Alright, so what I'd like you to do is, to the best of your ability right now, see if you can make a Pareto chart and a pie chart for these two data pieces, data sets, based on what you read earlier. Alright, go ahead and push pause. Alright, so Pareto chart. Remember, this is just a bar graph, and the only thing that's significant about this bar graph is when I put the bars on it, I'm going to put them in order from highest frequency to lowest frequency. So in this case, the ice cream flavor that had the most popularity will be on the left, and the ice cream flavor that was least popular amongst these is going to be on the right. That's really the only difference between a Pareto chart and any other bar graph. What I really would like you to think about, though, is what is the value of a Pareto chart over a pie chart? Be thinking about that. Even if you have to push pause here at some point to allow yourself a little more time to think about what that would be. So there's my Pareto chart, just a bar graph. Alright, now I'm going to move into a pie chart. And you guys have seen pie charts before. Alright, so what I'm going to do is I'm going to cut this circle, or cut this pie, if you will, into pieces that represent the frequencies of each of these. And really what it is now, it's relative frequency. So 41 out of, let's see what we got, 41, 71, 86, and 12, 98. So 41 out of 98, which is just a little over half, are vanilla favorites. Okay, let's see, chocolate, 30 out of 98. It's just a little over 30%. So again, you can think about how you're going to show that on your pie chart. Think about how you're going to do that. One way you might do it is take that 30 divided by 98 and then multiply that decimal by 360, which is how many degrees would be in your circle. And you keep figuring out what that is, and that would be how many degrees you would make that piece of pie in this pie chart. And so I got to work on my math here, figure out what that is. It's about 110 degrees actually. So I'm going to erase this line right here and build me a piece of pie that's about 110 degrees, so it's a little bit bigger than a quarter of the circle. So there's my chocolate. Chocolate lovers represent that many. Alright, continue to do the same thing with my strawberry now. Strawberry going to look about half of that piece that I just made, so about 55 degrees. And so I've got all of those percentages on there. Those are percentages, those are actually the raw values, raw data. That little sliver here is for cookies and cream, and then the very small one there is for Moose Tracks. So, question for you. And again, if you want to pause this now that you see both of these next to each other, what is the benefits or advantages of one of those? What is the disadvantage of one or the other? So again, if you'd like to take a moment to pause, do that. now. Alright, if you've had a chance to think about it, these are some things that I have that came to my mind right away. A benefit for a Pareto chart, very easy to see which ones are most popular. I mean, they're right there on the left-hand side. A benefit of a pie chart is the percentages. It's very easy to see what percentage of the whole population likes vanilla. A disadvantage for the Pareto chart, those are just raw numbers. So if those numbers are really, really big, that might not be a great way to go about doing that. I'm not sure about disadvantages for pie charts. I think maybe just ease of doing it might be a little bit of a disadvantage. Sometimes people have a hard time building all those pieces, the right percentages, the right chunks, size pieces of pie, if you will. Alright, last example, we'll look at scatter plots, and specifically, we're going to spend a lot of time with scatter plots in the next unit when we get back into the book. But we'll look specifically right now what's called a time series graph. All that means is what happens to some particular data over a certain number of years or a certain amount of time. So we're going to look at fuel economy of all the cars that have been bought during a certain year. So what its year is and what the miles per gallon fuel economy would be for all new cars bought. Alright, and I found some of this information the best I could just researching it real quick. And so these are rough estimates of what those miles per gallon would be for those years. And again, it's not just so much of you making this scatter plot right now, but looking for trends, looking for answers. So make sure you label those scales because those are going to represent different things. My x-axis is going to be the years. To me, that's the independent variable. My miles per gallon, the fuel economy, is going to be the y-axis. That's the dependent variable. You can figure out how you're going to represent those different scales as well. Alright, so what I'm going to have here, I'm going to have just a little scatter plot. I'm playing a little battleship. My x's are my years, my y's are my miles per gallon. I'm going to plot those points here. As you plot those points, again, look for trends. What do you see? I think the first obvious trend you see is as the years go by from 1960s towards the end of the 20th century, that miles per gallon is certainly going up. But then something happens and it goes back down. So a question you might be asked is what happened? What's going on here? What would cause those two trends? What would cause the events that you're seeing on the time series graph? What are the possible explanations for those things? I don't know, what could they be? Maybe for the first trend from 1960 to 2000, maybe you say that's just an increase in technology. Alright, we've developed better engines, ones that were more fuel efficient. But then what causes the last two to be like that? Maybe you say, oh, that's when SUVs got more popular and people sacrificed fuel economy for everything else that comes with an SUV. Alright? So hopefully these examples help you. If you would, please do the worksheet that comes with this video. Do problems 1 through 16. Thanks.